Hi guys, so today we shall complete our last part of our chapter 2 here by discussing the subtopic of the 2.2 techniques of differentiation. Here are the learning outcomes that we're going to see today. At the end of the lesson, students should be able to D. Find the derivative of the combination of the function using sum, product, quotient rules, and chain rule. E. Find the second derivative. So we will straight away to the question example 12. Find the derivative of fx equal to 1 minus 2x times 3x plus 2 divided by 5x minus 4. So for this question, it involves product and the quotient. Okay, let's see the solution. So for this one, first of all, before we differentiate, it's advisable we expand first. So here we will get the expansion 3x plus 2 minus 6x squared minus 4x divided by 5x minus 4. So while simplify it, we will get the answer negative 6x squared minus x plus 2 over 5x minus 4. So right now, we're going to use the quotient rule to find the differentiation for the function of fx. So here, first of all, we can just let the u as negative 6x squared minus x plus 2, v as 5x minus 4, which is the denominator, and then we can find the differentiation for both u and v. So for u prime, we will get the differentiation is negative 12x minus 1, and for v prime, we differentiate 5x minus 4, we get 5. Then now we can substitute the answer to the formula of quotient rule. So we have v, which is 5x minus 4, and then u prime is negative 12x minus 1 minus u negative 6x squared minus x plus 2, and then v prime, which is 5, divided by the v squared, which is 5x minus 4 squared. So the following just simplify the answer. So we're expanding the bracket there, so we will get negative 60x squared minus 5x plus 48x plus 4, and then minus, so this one you will expand with the 5, so you get this value, and then divided by 5x minus 4 squared. So here we're going to expand the bracket again, so you will get the full expansion here. Then we simplify again, and we will get the answer as negative 30x squared plus 48x minus 6 over 5x minus 4 squared. Alright, now we come to the end of the section of this chapter, which is the higher order derivative. So previously we have already discussed the first order derivatives, and now we will focus on the second derivative for this part. If y equal to fx, then dy dx or f prime x is called the first derivative of y with respect to x. So this is what we have discussed before. If the first derivative is differentiable, its derivative is called the second derivative of the original function and is denoted by d2y dx squared or f double prime x. This process can be continued to obtain the higher and higher derivative of f. Let's see the notation for higher order derivative. So here we got the y function and fx function, and if we differentiate it, so the notation for y can be written in two forms. Either you can write in dy dx or y prime. But for the fx, we will write it as f prime x. So this one we call it as first order derivative. Then if we differentiate them again, so dy dx differentiate, we will get d2y dx squared. Y prime, we differentiate again, we will get the notation as y double prime, while f prime x, you differentiate, again, you will get f double prime x, and this one we call it as second order derivative. And if you proceed to differentiate the second order derivative, then the notation will become d cube y dx cube. For the y double prime, we differentiate, we will get y triple prime, and for f double prime, we differentiate again, we will get f triple prime x, and this one we call as third order derivative. Let's see the example 13. Find the first and second derivative of px equal to negative 2x4 plus 9x cubed minus 5x squared plus 7. Let's see the solution. So we have px equal to negative 2x4 plus 9x cubed minus 5x squared plus 7. We want to find the first derivative. So the notation we will write as p prime x. And differentiate it, you use the power rule, which you get negative 8x cubed plus 27x squared minus 10x. And we do the second derivative, p double prime x. So differentiate it, we will get negative 24x squared plus 54x minus 10. Let's proceed to example 14. Find the d2y dx squared of f double prime x for each of the following functions. A. Y equal to 5x cubed minus 2x squared plus 7. B. fx equal to 7 over 2x minus 1 cubed. Alright, look at the solution. For A, we have the function y equal to 5x cubed minus 2x squared plus 7. So we want to differentiate this, we can use the power rule here. So the first derivative dy dx will be equal to 15x squared minus 4x. Then we differentiate the dy dx again to obtain the d2y dx squared. So this one, the answer will be 30x minus 4. So question B, fx equal to 7 over 2x minus 1 cubed. Before we differentiate it, let us bring the power 3 to the up become power negative 3. By using the general power rule, we can find the f prime x. So equal to 7. The power negative 3 you bring to the front, and then copy back the 2x minus 1. And then the power negative 3 minus 1, you will have negative 4. And we differentiate the function 2x minus 1 inside the bracket, so we will get 2. By simplifying the answer, so we will get negative 42, 2x minus 1 power of negative 4. So arrange again, where we will get negative 42 over 2x minus 1 power 4. So differentiate the dy dx again to get the second derivative, d2y dx squared. We will apply the general power rule again, which negative 42 we just copy back as a constant, and then differentiate the 2x minus 1 power negative 4. You bring the power negative 4 in front, then 2x minus 1 to the power of negative 4 minus 1, which is negative 5, and differentiate the function inside the bracket, 2x minus 1, that we get 2. Then we multiply the constant together, we will get 336 2x minus 1 power negative 5. And finally, we rearrange the answer and we will get like this. That's all for the lesson today. Thank you, class. See you again next time.